Hello programmers and welcome to your 51st chapter in your Java EE7 tutorial series. In this tutorial we'll be talking about transactions. A typical enterprise application accesses and stores information. Due to its importance, it must be accurate, current, and reliable. Data integrity would be lost if multiple programs are allowed to update the same information simultaneously, or if a system that failed while processing a business transaction were to leave the affected data only partially updated. By preventing both of these scenarios, software transactions ensure data integrity. Transactions control the concurrent access of data by multiple programs, and in the event of a system failure, transactions make sure that after recovery, the data will be in a consistent state. The topics we'll be covering here will be: what is a transaction? What are container managed transactions? And what are bean managed transactions? What is a transaction timeout? And updating multiple databases. So hold on, before we get into anything, what is a transaction? In Java EE, transactions are a series of actions that must be done to completion, or else all changes will be reversed. This is what we call commits and rollbacks. The Java Transaction API, or JTA, allows applications to access transactions in a manner that is independent of specific implementations. This makes transactions similar in different applications. An example of transactions would be like the one listed over here. Regardless of what happens, all these steps should be taken, they should all happen, or none of them should happen at all. These steps as a whole are called a transaction because they can't be separated. They're one whole unit and they should be all done once or none of them at all. So let's take a look into container managed transactions. In an enterprise bean, the EJB container sets the transaction boundaries, where the transaction begins and where it ends. Usually the container places these points right before a method starts and before that method ends. Some cases can be special, like in the next example over here. A transaction attribute controls the scope of a transaction. This becomes important in the figure over here. So let's say if a transaction is running method A and then it gets a call for bean to method B. So what should the transaction do? So should it run method B within the scope of the transaction? Or does it create a new whole transaction for method B? Well, the answer depends on the transaction attribute of method B. So transaction attributes can be like, for example, required, which will make the method execute within the transaction scope. If the call is not associated with any transaction before, it will create a new transaction. Requires a new, which will first stop the first transaction, start a new transaction, finish that new transaction, and then resume the paused old transaction. If the call is not associated with any transaction before, it will create a new one like normal. Mandatory makes sure that the method will only run when it's called from another client's transaction. You can't call it by its own transaction. Not supported. Well, if the client is running within a transaction and invokes the enterprise beans method, the container suspends the client's transaction before invoking the method. After method has been completed, the container resumes the client's transaction. If the client is not associated with the transaction, the container does not start a new transaction before running the method. And supports is like the complete opposite. If the client is running within a transaction and invokes the enterprise beans method, the method executes within the client's transaction. If the client is not associated with the transaction, the container does not start a new transaction before running the method. And finally, there is never. So this makes sure that the method never runs no matter what. And here's an example of these attributes in action. Right here you can see not supported, requires new, and required. So let's take a look into our bean managed transactions. Although beans with container managed transactions require less coding, they have one huge limitation. When a method is executing, it can be associated with either a single transaction or no transaction at all. If this limitation makes coding your bean difficult, you should consider using a bean managed transaction. So here's an example of what you might find. By checking various conditions, the pseudocode over here decides whether to start or stop certain transactions within the business method. When coding for application managed transactions for session or message driven beans, you must decide between JDBC or JTA transactions. The decision will make it clear later on. So transaction timeouts. Transaction timeouts can be useful if you don't want certain transactions to linger around too long. So let's quickly take a look at how we do that. Go into your Google Chrome and go into localhost 4848. Make sure that your Glacier server is running and go into server config. Open this guy up and go into transaction service. Over here, you will find transaction timeout. And let's set this to, let's say, 5 seconds. And go ahead and click save if you wish to do that. So what this does is essentially with this setting, if the transaction has not been completed in 5 seconds, the EJB container rolls it back. Okay, so let's get back to our thing. Okay, so now let's take a look into updating multiple databases. The Java EE Transaction Manager controls all Enterprise Bean transactions except for Bean Managed JDBC transactions. The JEE Transaction Manager allows an Enterprise Bean to update multiple databases within a transaction. In this figure, you can see that the client invokes a business method in Bean A, and then this business method begins a transaction in database X and Y. Then Bean A then invokes a business method in Bean B, which then creates a second transaction, which is done over here in database Z, and returns control to the business method in Bean A, which commits a transaction. All 3 database updates occur in the same transaction. In this next example, you can see that the client calls a business method to Bean A, and Bean A takes care of database X, and the different thing here is that then Bean A invokes a method in Bean B which resides in a completely different remote Java EE server. The method in Bean B updates Java or the database Y. The transaction managers of the Java EE servers ensure that both databases are updated in the same transaction. And that's it. That's all there is about transactions in Java EE and how it helps us out in our stuff that we're working on. So next in our Java EE tutorial journey, we'll be taking a look at using Java EE interceptors, and I'll be seeing you there in the next tutorial.